Alrighty, so in the previous video we were looking at how do we deal with certain types of modifications. I want us to instead now look at how do we deal with a situation in which we know the growth factor, and on top of knowing the growth factor we also know how often that growth factor gets applied. In this case we can use an equation that looks something like this. It's essentially a geometric model in which we've got some initial condition n0 and some growth factor to the power of t, but then we've divided by this factor d, where d is how often it should occur. So let's have a look at this one. An initial population of 2,000, n0 equals 2,000, increases by 7%. So increasing by 7% means that we're starting with 100%, we're increasing it by 7%, and so we get 107%, or 1.07 as our growth factor every 9 days. So that means d is equal to 9. Alright, so that means our model would be n of t is equal to 2,000 times 1.07 to the power of t over 9. So there's our model, done. And what is it saying? Right, start with 2,000, increase it by 7% every 9 days. So that's how it's all coming through. In this case, t is actually, and this is something we don't do enough, is set up our variables. That means n of t is the population after t days. Alrighty, it's really important to set up your variables to tell me what are we actually measuring. Alrighty, let's look at part B. Determine the population growth rate per day. Express your answer as a percentage, correct to 2 decimal places. Alrighty. So essentially, we can actually rewrite this. Let's start with this. This is our growth rate. 0.07 to the power of t on 9. And I want to write this as 1.07 or something to the power of t. So, using one of my index laws, I can actually write this as 1.07 to the power of 1 over 9, power of 9 times t, right? That's just what t over 9 actually means. And then using my index law, I can then write that as this. And so I can now work out what my growth factor would be by taking 1.07 to the power of a ninth, which in this case is 1.007546, depending on how many decimal places you want. It's going to go on for a little bit. There's no nice ninth root. Alrighty. So, in this case, our alternative function could be, if we wanted to do a daily function, is we could have something that looked like this. N of t is equal to 2,000 times 1.07546 to the power of t. Alrighty, so our growth model ends up being r is equal to 1.07546, and it wants us to write this percentage increase as a, I'm missing a 0. There's 2 zeros here. And so now it wants us to write it as a percentage. So 100%, well, this would be 100.7546%, take off the 100%, and we're left with a daily increase of 0.7546%. Alrighty. So this is just playing around with the idea of growth factors, and that even if a model is given to us over a specific day time, we can either write that using a formula that looks like this, or we can work out what the individual day growth is. Alrighty, that's the end of this one. I'll see you in the next one. Goodbye.